Okay, thanks for watching with the condensing and expanding logarithms on the front side here. As you can see, we have the TARDIS with lots of clowns coming out. Psycho, funny looking clowns, cute little ones. And so, because they're expanding, they were all scrunched up in that telephone booth, and now they're expanding and making it as wide and fat as possible. When condensing, you guessed it, they're all going to go back in the car. And so, starting here, we'll go ahead and start down here because we probably already did 1 and 2 in class, maybe 3 and 4 as well. So we'll start with an easy one, number 5, just to help you see how to expand these. So this multiplication means that we're going to expand it and it's going to become addition. But you're going to have a log base 9 with each one of those. So number 5 would be log base 9 of x plus log base 9 of y. And instead of multiply, we're going to do a plus, remember? Plus log base 9 of z squared. And then to finish it and circle our answer, you actually take the squared, and it actually goes in front. So that's where that 2 goes. We'll scribble it up there. And then there's our answer for number 5. See, these are pretty fast. Number 6 is a little bit more difficult. When you have a cube root, you got to write that to a power, an exponent, with a fraction. So number 6 is going to be log base 5, right? And then it's going to be w squared, and then u. So there's actually a 1 there. And so this is actually the number 1, u to the power of 1 over the root symbol, right? And so the root symbol is 3, so it's actually 1/3. U to the 1/3 is the same as the cube root. U to the 1/3. So you got to memorize that, know how that works. Okay, then once we do that, then all we have to do is multiplication between those two. So then we get multiplication becomes addition, so log base 5 squared, w squared, plus log base u 1/3. And then last but not least, we put the powers in the front like that. So then we have 2 log base 5w plus 1/3 log base u. And yeah, and that's it. So there's your answer there to help you on number 6. See if we can help you on maybe a more difficult one. So number 7 and 8, I highly recommend, actually, I don't think I taught this in class, but I highly recommend you just multiply that exponent through first, and then you could do it. So for example, log base 9, so this is actually u to the first power, and so why don't we just distribute that 5 through, so exponent to an exponent means to multiply, so this is going to be log base 9, and then it's going to be u1 times 5 is u to the 5th power. And then v to the 6 times 5 is the 30 power. There we go. And then I might even try to skip a step. Could you do it with me? I'm going to bring the 5 in front. So we get 5 log 9 u plus, bring the 30 in the front, plus 30 log 9, 30 log 9 v. So I kind of skipped a step there. I did addition as well as bring the exponent in front. So try that. Practice with number 8 there. Practice with number 8. Number 9 and number 10. So again, I'm not going to do the whole problem number 9 because we should have done one similar in class. But log base 4, you want to make x times y times z all to the 1/3 power, because those are all 1 to the 1/3 power. And then you're just 1/3 log 4x plus 1/3 log 4y plus 1/3 log 4z. And there's number 9 done, verbally. Number 10, you want to make this to the half power, right? Make it to the half power. So log base 7 of a times b times c to the 1/2 power, and you could multiply all those through. So a has a half, b is a half, c is a half. That's fine. We could do that. And or you could just bring the half in front first, maybe. And so if you bring the half in front first as a first step there, then we could just write each of those with pluses. So 1/2 log base 7a plus 1/2 log base 7b plus 1/2 log base 7c. And so that's, you have it. Expand it as far as possible. Don't pull out the half because we want it to be as wide as possible, as many halves there as possible. Okay, so then division becomes subtraction. Don't forget that. So for example, number 12, you would have to make this into 2 logs there. So log base 8x to the 4th is the first step. And then division is actually, doesn't that look like a subtraction symbol? It does to me. Even though it's division, it becomes subtraction. So then log base 8y to the 4th. So now we've expanded that and made that bigger from division to subtraction. And then we just want to put the exponents in the front. And then we're done. So 4 log base 8x minus 4 log base 8y. Bam! So that's how we do number 12, and very similar to number 11. So hopefully you're getting this here. Those look pretty similar there. I would distribute the 4 through first, so you have a to the 4th power, and then 4 times 4 is b to the 16th power, and then do subtraction. Log base 4 a to the 4th minus log base 4 b to the 16th, and then pull the powers in front. Okay, so now those ones are very similar as well. So ln is nothing huge, nothing way huge or different there. So for example, number 15, I would first write, instead of writing log, it's just the natural log. So let's just treat it like log. So ln, and we're going to do, so we're going to take that 6 and distribute it through. So we get ln a to the 6th power times b to the 24th power, because there's actually 1 there for the a, and then 6 times 1 is 6, and 6 times 4 is 24. And then we want to expand that and make it, so ln is just the natural log base e. So let's see here, so ln, we'll just do a to the 6th power plus ln b to the 24th power, and then put 4 in front. So then we get 6 ln a plus 24 ln b. There for number 15. We can go ahead and verify that for number 15. Let's see here. Yep, there it is, 6 ln a plus, there we go, 24 ln b. Okay. So yeah, so just treat it like log, log 10 basically. Just treat it like log. It's ln. So ln basically is the same as e. They're like opposites of each other. So like I was showing you before, e to the 1st power is like pi but different, 2.718, 28182, so forth. So ln is the opposite of e. So if we did, it's like the inverse. It's kind of like the log. Just like base 10 is the opposite of log, or log is base 10, right? So those are like opposites of each other. And let's see here. So is e and ln. So if I did ln e to whatever power, I don't know, squared, the ln and the e would actually cancel each other out, leaving you with just 2. So ln and e are like opposites of each other. If I did e to the ln of 2, that would also cancel each other out and give me just 2. Cool. So just treat it like just like in the previous problems, just treat it like the log, log. Cool. So do those ones as well. We'll jump over to the other side now where we're condensing now, condensing. So hopefully that's not too tricky for you. So we'll probably have done 19, maybe in 20 in class. So we'll jump back to those ones. And you know what I'll do? They're really fast. So all we do is the front and bring the 3 in the front. That's the first step. Bring the power. So we got log base 5 8 squared plus log base 5 11 cubed. Cool. And then we want to addition is what we have here, and so addition is going to become multiplication, right? So we'll just do one log now, log base 5. And then we'll do 8 squared times 11 cubed, right? So all we did was put the 8 squared and times it with the 11 cubed, just like we just multiplied those together. And so you can do that in your calculator if you want to get an answer. So log base 5, 8 squared. So we go 8 squared times 11. Probably get a massive, huge number. Let's see. Yeah, 85184. That's crazy. So 85184. So there's your answer. Log base 5, 85184. Yeah. Or I'd probably even accept that as an answer, but just in case, either put them both down. Okay, so now this one looks a little bit trickier, but it's not. So number 20, so a half is actually in front of the log base 210. And so we would actually write this to start condensing it. We'd first write it as a half log base 210 plus, because what this is actually 1 over 2. So it's actually a half when you divide by 2 like that. So then 1/2 log base 2 7 plus 1/2 log base 2 3. Cool. So then once we got all those halves in front, now we can put them all as the, we can move the power now. So the half goes in front of the 10, the half goes in front of the 7, the half goes in front of the 3. So then we have log base 2, 10 to the half power, and then plus log. He's out from underneath. You okay? Uh-oh. Log base 2, 7 to the half, plus log base 2, 3 to the half power. So now that we've got the powers in front, condensing it, see how it's getting smaller, condensing. Now all those additions becomes one multiplication. So now we have log base 2, 10 to the half times 7 to the half times 3 to the half. And since they're all to the half power, we can write them, and the half power means square root. So we can do log base 2, and then the square root of all those things multiplied together, 10 times 7 times 3. And so we could maybe even do that in our calculator. Let's see. So 10 times 7 times 3 is 210. I don't think there's a square root of 210, so we might just leave it like that. Let's see. Yeah, there's not really. So our final answer for number 20 then, for number 20, is log base 2 square root of 210. And there's our answer there for number 20, how you do those ones. And we'll just verify our answer there for number 20. Yeah, log base 2 square root of 210. Okay. So let's see here. So those ones don't look too complicated. Just bring the exponent up and then multiply them. Some of these you could even do in your head with one step. And so what you could do is you can already see to bring the exponent, and then you already know it's going to be a plus is going to become a multiplication. Do log base 3, and then we'll do what? A to the 12 times b to the 4th. Compact, condensed as much as possible. So that was pretty fast, pretty easy. Moved the exponent and multiplied the a times the b. Okay, so number 23 is kind of like number 20, so make them all halves. I mean, if you get really good at this, you can see what's going to happen. 1/2, and that means they'll all be exponent 1/2, right? Like that. So then those go away. And then you're going to do log base 2 and multiply them all. And so you'll end up with the square root of just x times y times z, because the addition becomes multiplication, and then they'll all be under the half, and the half is just a square root. Some of you don't believe me, so here's an example. Let's say 4 to the 1/2 power. Bam, it's just 2, because it's the same as just saying the square root of 4, right? That's what it is, same thing. Cool. Okay, now remember the subtraction becomes division for like number 24. So don't forget to put your exponents in front first. So we have log base 4, 10 to the 4th power, and then minus, so leave the minus there, and then log base 4, 7 to the 8th power. Cool. So then the minus becomes division with 1 log, so log base 4, And then 10 to the 4th, instead of minus, it's going to be divided by 7 to the 8th power. Now we'll see, and we could probably just leave it like that because I don't think that's going to reduce very well. We'll see. So 10 to the 4th power divided by 7 to the 8th power. And so yeah, it doesn't really reduce very well, so maybe we'll just leave it how it is because I didn't even see it turning into a fraction even. So we'll just leave that one how it is. Just leave that one. Thanks Bryce. I needed that. It's getting a bit sore with this arm.
Are you in a video?
I am doing a video. Woo! No, you're fine. You're fine. You actually, the microphone, yeah, the video's turned off. They only do voice because I was having problems. I know. Dang it. So the ln, don't forget you guys, the ln is just the same as log. Just treat it the same. Just treat it the same. So 30s go in the front as an exponent. So we have ln of 10 to the 30 power plus ln of 11 to the 5th power. And then combine those with multiplication. So we have ln of 10 to the 30 times 11 to the 5th. And you could probably just leave that how it is there. And leave that how it is. Or you can do 10 to the 30 times 11 to the 5th. But I think it's going to be a huge number. Yeah, just leave it like that. Just leave it like that. Okay, so get the rest of this assignment done. Thanks for watching. Thanks for watching. Don't forget when you have a fraction that it becomes... Yeah, class is starting. Don't forget when you have a fraction that it becomes just a fraction there of ln to the 3rd power. And then the exponents go in front. Yeah, watch my video. Woo, you'll be on it. Nice. Yeah. So this will just be ln 7 to the 5th power times ln, so then 3 to the 1/3 power. And I guess to finish it off, I don't know, 7 to the 5th, that seems like a humongous number there. Yeah, not too bad. 16807 times the cube root of just 3. Because 1/3 becomes the cube root. So either of those answers will probably be correct. Cool. So thanks for watching this video. Thanks for 7th hour being here and a part of the video. Whoop whoop. All right, so go ahead and say goodbye, everybody. 3, 2, 1.
Bye.
Bye. Yeah.